Let's explore how the system works. It has 4 defining characteristics. First, it uses 10 digits, 0, 1, 2, till 9. It groups these by 10, so 10 ones are replaced by 10. Similarly, 10 tens are replaced by 100, 10 hundreds are replaced by 1000, and so forth. Thirdly, it uses a place value, starting from right to left. So the first number represents how many ones there are, the second number represents how many tens there are, the third how many hundreds, and so on. So if we have 22 crayons, we will group 2 groups of 10 and we'll have 2 left over. We will write 22 like this. If we have 124 crayons, we have 1 group of 100, 2 groups of 10s, and 4 singles. We will write 124 like this. Finally, the system is additive and multiplicative. So if we take 124, the value of the numeral is found by multiplying each place value by its corresponding digit and then adding the resulting products. So the numeral value is equal to 1 into 100 plus 2 into 10 plus 4 into 1. 100 plus 20 plus 4, 124. It all sounds pretty simple and obvious, doesn't it? And that is exactly the advantage of the system. It makes maths simpler. How about zero? India was clearly familiar with the idea of zero. Let me give you some evidence. For that, we need to travel to the fort at Gwalior. Well, there is a stone tablet to the Gwalior fort that dates back to 876 AD. Now this tablet has a notation for zero. Not once, but twice. It mentions a piece of land that is 270 by 187 units long, and in the number 50, which refers to a daily gift of 50 garlands. This is the first recorded evidence of the zero we use today. Though some believe that Indian mathematicians like Aryabhatta and Pingala knew about it earlier. In fact, the Indian mathematician Brahmagupta also talks about zero. He writes that when you subtract a number from itself, you get zero. He added, the sum of zero and a negative number is negative. The sum of a positive number and zero is positive. The sum of zero and zero is zero. Now what made India's contribution revolutionary is the use of zero as a number rather than just a placeholder. This, combined with the other numerals, hugely simplifies all arithmetic operations. This knowledge traveled to Arabia, which was a huge center of learning at the time. When the famous Persian mathematician Al-Khwarizmi studied the system, he immediately saw this could revolutionize mathematics. Al-Khwarizmi was swift to take all these foreign symbols and ideas into his heart and mind and make them his own. His book, Kitab al-Jam wal Tafriq bil Hisab al-Hind, or Hindu Art of Reckoning, played a big role in spreading these concepts. This system then moved to Africa. A young mathematician called Fibonacci was exposed to this system as he lived in North Africa. He received an education from Moorish teachers. He realized that Arabic merchants were able to calculate much faster than their European counterparts, and realized that this was because they were using the Indo-Arabic system of numerals, which was clearly more efficient. Fibonacci quickly realized the advantages of this new system. When he returned to Pisa, he wrote a book that he finished in 1202 titled Liber Abaci, meaning Book of Calculating. This book dealt with the methods of arithmetic in the decimal system, and it eventually persuaded European mathematicians to drop the old way in favor of the new. These two systems led to a divide in Europe. In fact, there used to be mathematical competitions between the two. On one side, there were the abacists, who used an abacus, and on the other, algorists, who used the newer Indo-Arabic systems. There's a 14th century manuscript of Boethius's The Consolations of Philosophy. There appears a well-known drawing of this kind of competition that is being judged by the goddess of numbers. Now, Europe at this time was using the Roman numerals. So if you need to write the number 1999, this is how it would look. Now imagine adding and subtracting from this. Much easier to add from 1999, right? Now we know who finally won. By 1500 CE, the newer Indo-Arabic system had won and has persevered until today. The best way actually of seeing who won is by exploring the systems used today. Anywhere in the world, China, Arabia, Africa, Venezuela, languages, font, metaphors change, but the number systems are truly universal. That's all we have on numbers today. Keep watching the Maths Factor for many other interesting nuggets on the magic of mathematics.